So let's go ahead and get started. Today's presentation, we're really talking about the new updates on the 3D Experience platform since the last time I talked about it about this time last year. And really, that's mainly the introduction of a fatigue role, right? So durability is super important. We'll talk about why a little bit later in the presentation, but we've got a really nice story today around this Nemo submarine. And we can just run through and see some of the really nice updates to the simulation side of the 3D Experience platform. So for those of you who don't know me, my name is Steven Zalis. I am the simulation product manager here at CADimensions. So everything simulation related would run through me, whether it be the desktop tools, right? SolidWorks simulation, flow simulation, SolidWorks plastics, or any of the newer tools that we have access to on the 3D Experience platform. So just as a quick refresher overview for those of you who might not know what the 3D Experience platform is, it's a combination, joint effort from all of the brands of Dassault Systèmes, which is the parent company that actually owns SolidWorks CAD. And it allows us to connect people, ideas, and data seamlessly across the world from any location, right? It becomes kind of the single source of truth, the central operating system where all of the Dassault brands can communicate with each other, they can interact with each other, and we can do all of these really cool things, right? So why does that matter to us? Well, one, it's fully integrated with PLM, so product lifecycle management, and native CAD systems. So not just SolidWorks, there's also integrations with CATIA and a lot of the other CAD programs on the market. So no matter what CAD system you guys are currently using, it becomes accessible. And the fully integrated PLM, lifecycle management, revisions, history, all of that stuff is integrated directly into the platform. And it's a really nice simplified tool, right? We have simplified applications with tools specific for each domain, whether it's the design space, right? So SolidWorks, the simulation space, which is kind of where I hang out. We have manufacturing, we have lifecycle management, we have all of these different spaces where we can use all of the different tools available to us on the 3D Experience platform. So speaking of the simulation branch of the 3D Experience platform, what really is it, right? It's modeling, simulation, and visualization technology from a company called Simulia, which is the Dassault Systèmes brand that handles the simulation side of things, right? The desktop product, which is one of the industry leaders, is called Abacus. They've taken those solvers and integrated them into the 3D Experience platform across multiple different domains, right? So on SolidWorks Desktop, we really have three main domains that we are considering when we're talking about simulation. We have structures, right? So our typical front-end element stuff, which is comparable to SolidWorks simulation. We have flow simulation. We have injection molding, which would be SolidWorks plastics. But on the 3D Experience platform, we actually have four domains, right? We have structures, flow simulation, and plastics, so the good three that we have on desktop. And we actually also have electromagnetics engineering capabilities, which I'll be covering in my next webinar sometime in Q3. So stay tuned for that. The nice thing about all of these tools is they are fully integrated with the 3D Experience platform for easy collaboration with anybody who might need to see those results. And they are fully integrated with SolidWorks Desktop. And we'll see that in this presentation, how easy it is to push and pull that data out of the platform, just like using SolidWorks Desktop PDM. But in this case, rather than connecting just to a single file server, we have the ability to connect from anywhere in the world and with anybody in the world. So we have three key points that I want to just hammer home. You guys have probably seen these in some of my other presentations, which are kind of our value drivers for 3DX simulation, right? We can analyze certain classes of problems that maybe desktop can't handle or would be very difficult to handle. The big one is collaboration, right? We want to make sure that we can collaborate with whoever needs to see those results, whether it's the design team, engineering manager, the CEO, the CFO, whoever's making the decisions behind the scenes. We can certainly get that data to them very quickly and manage that data, right? It becomes very easy to manage all of the associated simulation files and file sets and all of that stuff that would typically eat up a lot of space on a desktop hardware solution. It becomes very easy to manage on the 3D Experience platform. So now that we've got all of our different summaries, right? We've got our summary of the 3D Experience platform. We've got our summary of the 3D Experience or the simulation branch of the 3D Experience platform, I should say, so the domain that really I live in, we can now get into some of the updates, right? So the 3D Experience platform, just like SolidWorks Desktop, runs through multiple iteration cycles, multiple update cycles every year. And I want to just highlight some of the really nice new things that we can do this year that, like I said, maybe we couldn't have gotten to last time I covered this topic about a year ago. So when we test our products, whether they are virtually, right, with simulation, whether it's SolidWorks simulation or 3D Experience, or in the real world, we're exploring numerous design options, typically evaluating, hopefully, how long those products will last and finding out when and where ultimate failure may occur. So we can kind of push the limits of our design envelope. And we can do a lot of that virtually, which is a key when we are dealing with the design phase, because we don't want to have to spend the time making multiple different prototypes and breaking multiple different prototypes, right? So it's no easy task when we have to manage all of these different pieces. When we have different physics, different loading scenarios, collecting the data, managing the data, making sense of all that data can be really daunting and time consuming. However, when the design and analysis tools are disconnected, it becomes even harder, right? There is a solution though. We have obviously our 3D Experience platform. It provides our world-class Abacus solutions, industry-leading, including Abacus technology, FE Safe technology, which we'll talk about in the durability role, all of these different world-class solvers right at our fingertips. And the best part is it connects seamlessly with SolidWorks, which we'll see in just a second here. So in this case, we have our analyst here, and he's working on our submarine, and he has to help satisfy their safety and certification requirements. So really, he's got 3 separate tasks to run, right? He's got a couple of different things. He has to explore different design spaces. So we have to run what we would call in SolidWorks simulation a design study. We'll see if we can add that to our platform repertoire as well. Evaluating its durability and finding out what happens if the Nemo gets too deep under the sea, and kind of basically pushing the limits and seeing what the limits of our design space are. So in this case, our depth rating is supposed to be about 100 meters. Our battery compartment has to obviously withstand all of that hydrostatic pressure. So what we are going to do is specify some design variables in here. And it's as easy as opening up the part and declaring those variables as what we call parameters, just like I mentioned before. If you guys are familiar with SolidWorks simulation design studies, exact same process, right? We can take those parameters, we can declare them as variables or parameters and feed them into either a SolidWorks design study, or in this case, we're going to do our design exploration on the 3D Experience platform. So what we can do is save that model with those parameters defined into the 3D Experience platform, and we're going to open up something called the Model Assembly Design app to start our simulation process. And what that's going to do is it's going to kick off the mesh creation, right? So we have on the 3D Experience platform an automated mesh creation, which is really nice because we can pick a mid-surface mesh and work with shell elements rather than having to define or set up all of those shells manually in SolidWorks simulation. We can use the mid-surface mesh procedure and do it in one click, right? It's going to create all of those meshes, and it's going to create all of the associated bodies all in one command. The next thing we're going to do is feed that into our structural scenario creation, and we're going to create a static step, and we're just going to define our pressure loading, right? We're going to add a fixture to those 4 bolt holes we can see down there, and we're going to add our pressure to the outside faces of this submarine container, because again, we're dealing with this container under the sea, so that hydrostatic pressure in this case is just going to be applied on the outside. If we take a look at the results, right, we can simulate it, take a look at the results. It's pretty obvious that our structure is too thick. It's a little bit over designed. So what we can do is launch our parametric design study application and optimize those variables, right? We have our design variables manager, which we can specify our minimum and maximum. We can specify our parameters. We can specify the goals of interest, right? If you guys are familiar with design studies on the desktop side of things, it's exactly the same process, right? We have our variables, we have our constraints, and we have our goals, whether it's to minimize mass or it's to maintain a specific stress level or whatever our goal might be. We can certainly do that, and we can let the 3D Experience Solver do the rest of the hard work, right? It's going to go ahead and run all of the design exploration study, and we can easily pick and choose and compare the performance of all of these different design variables across multiple different responses. And in this case, we are looking for our mass and our von Mises stress in there. Those are the two things we're comparing against. And we can even highlight the best design and actually create a new design point. So in this case, we've added the prefix best for our design, and it's actually going to take those design files that the simulation has created and create a new version of the assembly with those models. So in this case, this is actually a two-way street. The parametric design study will read variables in from SolidWorks, and it will actually, SolidWorks will read the new variables back in the next time you open that model. So it is a two-way street, just like it would be with a desktop design study. The variables are all two-way, right? So if we use the design study to update our model, the variables will be pushed into the part the next time we open it. Those dimensions will change, or those mate angles will change, or whatever it might be that we're optimizing, they will change the next time we open the part. There's no difference there between the 3D Experience platform and desktop SolidWorks. So we've got our new parameters, and next time we open that file, we will use those new parameters. But in this case, that's only the first task we have to do, right? We have our design exploration, our automated optimization works identically to the desktop version. It's just really nice to have that option on the cloud as well. The main new role or new capability that we have this year is durability and fatigue. So what we can do in this case is now take our pressure study that we created before. That's going to happen multiple different times, right? We have our pressure study, and we also have the other loading condition is the skid impact when we store the submarine, right? So in this case, we're going to use an explicit dynamics study to capture the super highly changing stress from the landing cycle. And we are going to just use the default general contact in the 3D Experience platform to allow the solver to figure out what pieces are coming into contact, rather than having to set up multiple different contact sets or contact interactions in desktop SolidWorks. It becomes very easy. You can just hit one button, say general contact, let the solver figure it out, and not even have to worry about it. This is one of my favorite features in the 3D Experience simulation domain, is the ability to just say, here is my general contact. Anytime you get two bodies that are going to be coming into contact, or two faces that are going to be coming into contact, use these properties. Contact sets are a thing of the past. It becomes very easy with the general contact here. So we can specify our explicit dynamics study. We're going to go ahead and run this on the cloud. It becomes really easy to leverage the high performance computing power, and we don't need expensive desktop hardware. I've talked about that in other webinars that we have, that we show the value of using the cloud rather than maintaining expensive desktop hardware, but we can go ahead and execute on the cloud and come back to get our results. So now we're taking a look at our explicit dynamics study, right? We can see our skid being dropped or lowered onto the storage platform. We can see our stress values are within the expected range, but now we're dealing with fatigue, right? How many times can our submarine battery container withstand both this and the pressure load? So we're going to go ahead and set up a durability study. We're going to take the pressure loading, the last increment, because that is a static study. So we're just going to go ahead and take the maximum pressure. And we're going to take every increment for our explicit dynamic step. So for the pressure study, we specify the last increment because that is a static study. For a dynamic study, things that are changing very quickly, the stress field is changing, all of that is changing. We're going to take all of those stress fluctuations and use them in our fatigue study. So this is a really cool aspect of fatigue on the 3D Experience platform. We can do both high cycle fatigue and low cycle fatigue, right? So low cycle fatigue means high strain fatigue or plastic fatigue, deformation, things like that, where we have these nonlinear effects. We can capture that with our fatigue solver on the 3D Experience platform. We can use an explicit dynamic study or a nonlinear study or things like that, where we're dealing with plastic material responses. and we can go ahead and feed those into our fatigue study as well. So we can include both stress and strain to improve accuracy and solve for high and low cycle fatigue, right? High cycle fatigue is hundreds of thousands of increments. Low stresses, they typically build up over time. Low cycle fatigue is strain-based fatigue, where we have really high strains or very violent deformations, and we can use that for our fatigue analysis as well. So we can include both stress and strain. So the last thing we have to do in this case is we're going to turn off something called inter-event transitions, because these sequences occur in the loading history, but they do not occur at the same time. So we just have to turn off the inter-event transition option. And then the last thing we're going to do is specify our base surface finish. So in this case, we can go ahead and specify our surface finish, and we get our fatigue life plot, right? Our log of life. So the next thing we can do is take a look and show these results on the 3D Experience platform in an application called Physics Simulation Review. They are available not only to add-on, but anybody who has access to these files, right? So just like in PDM, you can define read and write access to specific folders. Same idea on the 3D Experience platform. You can grant access to anybody who might need to see these files, and they can take a look at them in the web browser, right? They don't need to download the giant results data set to take a look at these results. All they need to do is have access to the file. They can take a look at the file in real time on the 3D Experience platform anywhere that they would have an internet connection. So they could be at the cafe, they could be at their desk, they could be on their phone, they could be wherever they might need to be, and they can have access to these files. So it becomes super, super portable and very easy to share all of this data with, again, whoever might need it. So our durability is super cool, right? We have our comprehensive fatigue life evaluation. We have stress and strain-based fatigue. So we have high and low cycle fatigue, which is something that SOLIDWORKS desktop simulation does not have. We do have fatigue calculations in SOLIDWORKS desktop, but they are only high cycle fatigue. They're only stress-based rather than strain-based. So we get a little bit more information using the 3D Experience platform. I'm going to take a little bit of a detour and just talk a little bit more about why we want to focus on durability requirements, or why we might consider something like this, right? The first thing is that there are every year more and more fatigue requirements on new products, right? It has to last X number of years. It has to last X number of cycles. We want to guarantee performance up to this specific time frame. The only way to do that would be to either cycle it through, right? So build a prototype and cycle it through, or run something like this, where we have our fatigue calculations allow us to take a look and see and predict how long these things are going to last. The other option, or the other current issue, is that current methods are time consuming and expensive, right? It takes a long time to build one of these prototypes. It's typically expensive to build a prototype. The testing methods are exactly what they sound like, right? If it needs to run or be certified for 7 million cycles, we need to run it through 7 million cycles. And that can take hours, days, years, whatever it might be. It takes a really long time to run something through a full life analysis. So the more we can do it virtually and let the computer do the hard work, the easier it is. The third reason we might want to consider durability, or why people are considering durability, is unreliable products equals more warranty claims, right? So you have to replace the product, or I should say, consumer mistrust, right? Why am I going to buy a product from you if it breaks after 3 days or 3 years, whatever it might be? We want to make sure that we can maximize durability and maximize the lifespan of these different products. Where these considerations become super important, right? Some typical applications: industrial or mechanical equipment, right? So like if you buy a new car, you get 3 years or 100,000 mile warranty on your drivetrain, because those parts are certified to last 100,000 miles, or they're supposed to last for 3 years, right? All of that stuff has been tested and proven. Those numbers don't just come out of nowhere. That is a great example of the durability studies and fatigue analysis on specific parts. Another really important industry where a lot of this stuff is coming into play is medical implants, right? Hip replacements, knee replacements, different things like that, that once it's inside of the patient's body, it's very difficult to have to replace it. So we want to make sure that things like that are maximized for their specific application. The hip implants especially, right? A hip replacement is no joke. It becomes very important to make sure that the part is going to last as long as possible once it's inside of the patient's body. A third example is obviously consumer electronics, really anything that is going to have a warranty attached to it. We want to make sure that we try and maximize the life of that product or that component. But durability can help do that, right? We can go ahead and run our studies and then just feed those into a secondary study for our fatigue analysis. So it becomes very easy with the tools available on the 3D Experience platform. It's really just another step in the checklist, but it becomes very important if we're dealing with things that have potential failure rates. The last piece of the story that I wanted to share with you guys is the worst case scenario. This is another new option in the 3D Experience platform that was updated last year, is to identify ultimate failure on our battery component, right? If our battery component or our submarine gets too deep, we want to see what happens, right? So in this case, we're going to take the existing simulation setup and set up a new study called a RICS buckling step. And this is exactly the same as a buckling study in SolidWorks Simulation Desktop, but the RICS buckling step, it is a little bit more advanced calculation than the typical buckling analysis available in SolidWorks Desktop. It's really well suited for nonlinear collapse like this, where it's just hydrostatic pressure. It's going to buckle if this thing fails. And it doesn't require setting up a really complex dynamic analysis at all, right? It's a super easy calculation. All we have to do is just say static RICS step, and it will calculate all of the buckling behavior. It will calculate the buckling shape. It will calculate the load factor, right? So the load factor in this case is over 7. So we can go 7 times deeper than what we had planned for. That's kind of our maximum load limit in this case. And we can visualize which areas of the compartment are going to fail first. So we get kind of the full picture. We get the shape, we get the load factor, which is the multiplication factor with our initial load. So our initial load in this case was about 100,000 PSI, and we can go ahead and multiply that by 7, and that's roughly the depth that we can get to before this thing is going to start to crumple under the pressure of the water. So it becomes super easy to share these results as well with our stakeholders. Again, whoever might need them, we can set up multiple different physics simulation review widgets. We can look at the lifespan, we can look at the pressure, we can look at the displacement, we can look at whatever we need to look at to get the complete picture in this case. And this is all web browser based. It's very easy to get these results to whoever might need them. They can be shared without the need to export them or email them or download them. Everything is in one place on the 3D Experience platform. Becomes super, super easy to run through the simulation workflow with the 3D Experience platform, right? We can use it to explore different design options, which we saw in the first step. We can evaluate our durability. We can take a look at the critical load to make sure that this thing is not going to break on us and we know our depth limits. And we can help fulfill safety and certification requirements for this specific part, but really for any specific part. Everything's got different requirements. We can certainly use the 3D Experience platform to meet all of those different requirements. So just as a quick review, guys, I'll let you go in a couple minutes. We have the 3DX simulation branch or domain. We can create complex simulations and leverage our cloud computing power to solve. We don't need expensive hardware, right? We can go ahead and set it up on a very easy local install of the 3D Experience platform. We don't need super expensive hardware or very fast processors or lots of RAM, anything like that. We can use the cloud computing power to do all of the hard work, and we can just use the 3D Experience native application to set up all of the pre-processing stuff. One of the things that I was trying to hammer home during this presentation is the ability to communicate ideas, design changes, and updates super easily, all in one place, right? Any spot that we need to share that data, we can just give that person access, and we don't have to worry about chasing emails around or chasing file sets around. making sure we have the latest version, anything like that. It's all in one place, that single source of truth for all of our data. And then again, just to go back to the data management side of things, right, we can manage our simulation and all of our other cloud data, or CAD data on the cloud, I should say. We can make revisions, we can make changes, we can do all sorts of stuff right on the cloud, and it becomes very easy to work with existing files and non-SolidWorks CAD data as well. The cloud is CAD agnostic, so we can go ahead and use different CAD data to feed into the simulation side of things. But if we're using SolidWorks data, right, as of the latest release, we have full support for SolidWorks custom materials. So I know a lot of customers have custom material databases that they've been using or curating for years, and they take them with them year over year as they upgrade versions of SolidWorks. We make sure we keep that material database updated and carried forward to the next version. We can also import that directly into the 3D Experience platform. So all of your custom material data that has been curated year over year will be, or can be, imported directly into the 3D Experience platform. So if you have all of your test data and all of that stuff, we don't have to redo any of that. It's all going to be ported over and converted as of this latest release. So it's a really nice new feature I just wanted to highlight. So if we're making the jump, or we're thinking about making the jump, the custom materials will come right with you. We don't have any rework or anything like that to set those back up again. All we have to do is import the material database library file and let the platform do the rest and sort it all out on the back end. That's all I had for you guys today. There is my email address is up on the screen. If you guys do have any follow-up questions, I will leave the chat open for a couple minutes just in case you guys have anything you want to discuss. But other than that, thank you for sticking with me, and I'll see you guys next time. All right, so there was one question in the chat. How does 3DX compare to ANSYS use? That's a great question, Charles. They are very, very similar. Everything that ANSYS can do, the 3D Experience platform can do as well. As far as I'm aware, I have not gotten super hands-on with ANSYS. I've used it a couple times in the past, ANSYS Mechanical, but everything that I've seen ANSYS can do, the 3D Experience platform can do as well. The one nice thing that the 3D Experience platform does have over ANSYS is the ability to use cloud computing, right? The ANSYS licensing, as far as I'm aware, is core lock licensing on your own machine. And I believe by default, it comes with 4 cores, and you can pay to unlock more of your cores on your machine, I think up to 8 cores. With the 3D Experience platform, you get 8 cores for free, either on your machine, or you can use 8 cores on the cloud. But if you want to, you can solve on up to 144 cores on the cloud. So if you have a really, really difficult simulation or something that's going to take a while to run, you can upgrade up to 144 cores and run it on the cloud. They are very, very fast solvers. I've run analyses that I thought were going to take hours to run, and I've run them in under an hour on the cloud. So the capabilities, as far as I'm aware, are almost identical. The user interface, I do like the 3D Experience user interface a little bit more than the ANSYS interface, but the capabilities are the same, and we have more cloud computing capabilities because, as far as I know, ANSYS does not have any at all. All right, guys, I'm going to go ahead. Oh, one more question. We have a unique PDM system. Can this be used without using the 3DX PDM? That is a great question. The answer to that is I don't believe so. I believe it's all tied to the 3DX PDM. What you can do, you can use them independently. So you, I believe, can add both the SolidWorks PDM add-in in as well as using the 3D Experience add-in into SolidWorks. There is the only problem or difficulty that I would see would be that I don't believe both systems can talk to each other, right? So you can import directly into the 3D Experience platform by opening up just a CAD file, whether it's a SolidWorks file, an NX file, or a CATIA file, whatever it might be. You can open it up in the simulation application and do all of your work and go from there. That data will automatically get saved into the 3D Experience platform. There's no way to tie that data into your PDM system because it's written in a different format and they're kind of kept separate. However, you can use your desktop PDM system with SolidWorks and do all of your design changes and revisions there, then what you can do when you're ready to run a simulation is pull that file out and put it into the 3D Experience platform. It's a little bit of a pain managing both systems, but I believe off the top of my head that it can be done. So if you need to use the advanced capabilities for a simulation you have, you can pull that system out of, or pull that file out of the vault or make a copy, throw it into the 3DX simulation application, run your simulation, and that will be saved into the 3D Experience PDM. There are ways to pull it back out of the 3D Experience PDM, but it would be a little bit difficult managing both. I don't think it's impossible, but it would require a little bit deeper conversation. No problem, Charles. If you guys have any other questions or anything comes up, feel free to shoot me an email or submit a tech support case on our website, and we can certainly get back to you. I am going to shut the meeting down, but like I said, if you guys have any questions, feel free to shoot me an email, and enjoy your morning, guys.